Well, in this modern world, we have two options. We can make a model out of cardboard, tape, and paper, or we can make a model in a computer and then run animation software and whatever. For this, I chose to examine a transformation of one polyhedron into a couple of other polyhedra using cardboard. I mean, I do have a fond spot in my heart for this old ATI video card box. I also had a kind of a hankering for some sweet little Debbie stuff. This is an octahedron, 8 faces, equilateral triangles. Okay, that's the way it looks in real life. This is it spinning around on various of its axes of symmetry. The vertexes there are pivots in pairs of vertexes here. So it will unfold, and here it goes. The website accompanying this video shows diagrams of the intermediate stages here. You can see there's like little diamond-shaped openings forming. For instance, these two vertices open up and start to move apart. Whoops, let me do this no more. Start to move apart. And then they get to some maximum point. Who knows exactly what the maximum is here? We'll think about that mathematically, but the transformation happens. What we're looking at is at some point the space between these two opening vertices here is the same as the side of one of the triangles. At that point, the faces, possibly it's here, possibly it's around here somewhere, it's somewhere in here. Before we get here, which is a cuboctahedron for those of you who love such things, after we get here, it's opening up, and around here somewhere, the length between these two vertices is the same as the length of a side here. That's the icosahedron. Anyway, notice about the model. Basically, it's just a bunch of triangles with these odd little fan-fold kind of fan-fold little vertex connectors. They're designed to kind of fold up and kind of get hidden in an approximate kind of way. As you can see, they're non-ideal, but they're a lot easier than any of the other. Where's that? Where's my cover again? There we go. The final intermediate form here is polyhedron composed of equilateral triangles and squares. The squares being virtual, if you will. The famous cuboctahedron. But this is a lovely transformation. Equilateral triangles making up an octahedron through intermediate forms, unfolding, hinging in 3D space at the vertexes, going through the cuboctahedron, which is basically a truncated cube and or a truncated octahedron, through the icosahedron again, and back down to an octahedron. Let's do that again with another pair of pair of vertices. It's a lovely little thing. Oh, it's kind of sticky. Zip, 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 zip. Make one, play with it.